Hi everyone, I'm Chetan Khatri. I'm a technical lead and data science practice leader at Axion Labs India. So today I will be talking about no more struggle with Apache Spark, means PySpark in production. So I will share my experience that I have worked with almost 4 to 5 years in Spark and Scala and Python. So about me, as I said, I'm a technical lead and data science lead at Axion Labs, and prior to that, I worked with Nazara Games and Excella Corporation. I did MSc in computer science from Kutch University in India, and this is agenda what we are going to talk about. So I will set the context by introducing the primary data structure of Spark, RDD, DataFrame, and dataset, and then I'll talk about the pragmatic explanation of executor course, container state, job, and a task in Spark. And I'll talk about the difference between JDBC read that you do and that is parallel or not. I will talk about how you can do parallel and purely concurrent JDBC write in Spark. And I will talk about how you can avoid the unnecessary shuffle and join strategy. And after that, I'll talk about some of the known issues in Spark which you cannot do. And then I'll talk at the end about power of Chorus and Delta, which got just open source 1.5 months ago. So coming to the point, yeah, so how about Apache Spark? So Apache Spark is the unified data processing framework till now, but now it has got added with machine learning and AI. So you can do Spark Core, Spark SQL, you got Spark Graphics, and you got Spark MLlib. So what is RDD? RDD is the primary abstraction on the Spark called resilient distributed data set, which gets splitted across the cluster and get parallelly executed. So you can apply your lambda function on each split and get processed data. It is resilient and immutable, means you cannot change the format and the data of the RDD, because that's how it will be thread safe. And you can create the compile type safety and strongly type inference with the Spark, means you can create the RDD of integer, RDD of string, and any primitive type of data that you want. It has lazy evolution, so when you create your transformation, it generates the directed acyclic graph, and from that it started executions. So saying that if you have the analysis error, when you execute your action, it will get exception. Means if you are trying to read the file and that file has a wrong format or file doesn't exist, those exceptions you will get at the when you call the action like save. So Spark got so many operations like transformation and action. So Spark as a library has support of widely all the functions and available theory like statistical and set theory, and you can have the lazy evaluated actions that you can see here. So the question is that when to use the RDD, okay? So if you don't care about the control of data set and you know that how it looks like, you care about low level API, you can use the RDD. If you don't care about available lambda function in the Spark DSL, you can use the RDD. If you don't care about schema and the structure of the data, you can use the RDD. If you don't care about the optimization and performance that you can gain, you can use the RDD. And very slow on non-JVM languages like Python and R so far, but what I will tell after this will tell you that how it can be faster with Python also. And if you don't care about inadvertent inefficiencies, you can use the RDDs. What does it mean? If you can see this example at line number 14, sorry, at the line number 15, what I'm doing is that I'm doing reduce by key. So which does the shuffle across the entire cluster, and then I'm saying the filter, okay? So the order of the function has not correct here. If you can do filter first and then do reduce by key, you get only those data that you need, and then you can shuffle that, okay? So what are the structured API available in the Spark, DataFrame, and dataset, okay? Since dataset has no support in PySpark because the dynamic programming nature of the Python, and it is already been available with Python. So I will skip that here. Apart from that, the one difference that you can see in the RDD and the DataFrame is that DataFrame by default you get 200 number of partitions. So if you have more number of partitions, you can create more number of parallelism and concurrency in a Spark. So your performance, you can boost it out. So when you create the RDD, by default partition is 4, and when you have the DataFrame, the default partition size is 200. So if you care about strongly typing, ability to use powerful lambda functions, if you take care about all functional transformation, you can use the dataset. And if you can see the structured API in Apache Spark, so if you have a syntax error or the analysis error, you can catch at the runtime if you use the Spark SQL. But if you use the strongly typing, you can catch at the compile time itself. This is one example that you can read with the DataFrame here, and same example if you use the SQL, you can use the SQL here. And it is supported and optimized by Catalyst engine in Spark. That does mean you get DataFrame, dataset, and SQL AST, and that generate the unresolved logical plan, and it will generate the physical plan, and then it will execute the cost model and choose the best physical plan, and then it will generate the high level RDD. So this RDD that you can see at the end, it is not the exactly that I was talking about before. This is highly object optimized JVM bytecode which execute on top of the JVM. So how Spark execute that? So Spark uses the Python uses the Py4j for the driver node. Apart from all the worker node, they use the Unix pipe to communicate with the JVM. So this is one example that how you can have DataFrame optimization. So if you use the DataFrame, you get query plan optimization that you can see in this example. So first you get the logical plan, and then if you have two files, one is you have Parquet events, and second you have is the employee table. So if you know that before you join, you can filter it out the data, you bring the only data that you need, and then you join it. So Spark supports the predicate push down and the column pruning. So whatever you need, it will generate the best physical plan for your query engine. And this is one of the comparison of the DataFrame and RDD in terms of performance. So if you use the dataset, it is better in serialization also. So now I will talk about the project called Apache Colas, right? So can you see the screen here? So the library called Colas. How many people of you are working with pandas? Have worked with pandas? So pandas runs on single thread in the Python, okay, and it tries to fit everything on single set of data block. But 1.5 months ago, company behind the Spark, Databricks has open source library called Colas, which runs parallelly, and there's no need to cast in between pandas DataFrame to Spark DataFrame, vice versa. This supports the highly native Spark APIs, and in terms of performance that you apply is very faster than pandas. So in this example, you can see here I got Spark session, then I have pandas here, then I have importing the from Databricks import Colas, and then I'm creating the Spark session object, and then I'm reading the one CSV file, and I have time here that how much time it took, and then I'm using the Colas. Just you need to replace your PD object of pandas with Colas, and everything works as it is, okay, and that DataFrame is supported natively with Spark. And then I'm seeing the how much is the shape. So I got 51 500k rows and 40 columns here, and then I'm selecting this. You can directly do value counts, means it can give you the product wise group by here, which you can see here. How many people of you are working with the one hot encoding when you have Have someone tried one hot encoding when you have categorical data and when you want to set the values 0, 1 based on the categorical data? So if you do here display colas.getDom is final data and the column name product, right? You can see the one hot encoding here. Okay, so it is supported in this way with the visual way here. Yeah, coming back to the slide. So after this, I will talk about one more open source project which supports the. So when you create the big data architecture, so what happened? The Spark is not only used for unified big data processing, but for applying ML and AI. Because when you create your statistical model with a deep learning or TensorFlow, you think that same process data is available at your data lake, right? So why can't you directly read from Parquet? Why can't you directly read from Avro rather than generating something else? And when you build your architecture, you understand that AI and ML will be integral part of your application or platform. So there's no need to create separate environment, separate infrastructure, and separate team, but same people can work with same infrastructure. So coming to the point, it's just not only optimization of the library or your DSL code, but you have to also optimize your infrastructure. So if you understand that the terminology and the internals of the Spark, which helps you to write the code the way it likes. So I'll talk about every internal things like job does mean that each transformation and the action that you apply on a Spark would create each separate job in a Spark. Stage means a set of tasks in each job which can run parallel using a thread pool executor. And task means the lowest level of concurrent and parallel execution point here. And each stage is split into number of partition tasks, right? So each stage will have the data frame, and data frame will have n number of partitions. So the number of tasks that you can run on the cluster would be staged into number of partition in the stage. So in this example, you can see that this is a job, active job, and this is the stage here that you can see. Inside the stage, you will have a number of tasks here, and the number of tasks can run parallelly on different executors, right? So executor is nothing but the different various JVM box that you can run here, and those are virtual. If you run on top of the Yarn or Mesos, Yarn will provide you containerization, and each container will be virtual here. And you can see here the parallel task execution in the Yarn or Spark UI. So how it works internally, if you can see here that maximum allocation vcalls is 6 here, right? And if you can see that active nodes are 4. So maximum allocation into active nodes, that does mean total virtual core that you got in the Yarn. That does mean if you see the configuration that yarn.scheduler.allocation vcalls is 1, right? So minimum is 1. Here you got maximum is 6. Okay, so when you submit your Spark job, you provide the executors and cores, right? So those cores are here. So if you configure in this way in a setting, and then you tell when you submit your Spark job, here if you provide 6 virtual cores for Spark job, then you can run 4 Spark job here, because 24 by 6 4 jobs. If you provide virtual cores 1 in a Spark submit, that does mean you can run 24 Spark jobs parallelly, right? So you have to decide that which job is CPU intensive, which job is in memory intensive, and which job is a disk intensive. Also, I mean, generally, if you have some time and then you would like to pick the first row by sorting that, right? So if you do in this way, which you can see here, you first sort it by update time in descending order, and then you drop duplicate on any primary key. This will not be consistent in Spark, because when you do distinct, you don't know which one they will keep and which one they will drop it. But if you want to make it consistent, why it's not consistent? Because the drop duplicate is not consistent across all the partitions. you have got here DataFrame here, and it has, for example, 200 partitions. It's not consistent. But if you want to just try and see that how you can make drop duplicate in this way and consistent, you can do DataFrame.coalesce and provide 1, so generate only 1 partition and then apply the drop duplicate here. But you will get performance penalty here, because if you get 1 partition, you will not get parallelism and concurrency on Spark. So one executor will only run on top of that. So how you can get this problem solved without getting penalty of the performance? You can use the window function from the Spark, and you can do window.partition by and order by update time, and then you add one more column and provide row number over window specification where row number is 1 and drop that value. So here, this way, you can get consistency of the first row here. Yeah, so apart from that, what kind of tuning can be done is hyperparameter and configuration tuning. So if you can see here spark.speculation false. So speculation means that identify some of the tasks which are running too late and restart those tasks. That does mean speculation. And this is a dynamic allocation. That does mean you allocate resources to your Spark job dynamically. Yeah, that's it. Any questions?